Hello YouTube. Today I thought I'd explain something about transistors because I kind of glazed over them before. I wanted to make a fuzz pedal for my brother, and Josh from GHS Pedals said that you have to know what the HFE or beta value of your transistor is if you are building a fuzz pedal. So let me get into explaining what that is. The most common transistor type for pedals are BJT NPN transistors, and the symbol for those is this circle with this arrow. This pin is called the base, this is the collector, and this is the emitter. And if you have this in real life, you can find on the data sheet of your specific transistor type that will be written on the flat side of the transistor. It will have 3 legs, and either of these legs can be any of these. And that depends on the type of transistor, so you have to look that up. Commonly the base is in the middle, but not always. And then this could be the collector and this the emitter, or the other way around. In any case, what is the beta or HFE value? Well, it is defined as IC over IB. Okay, IB is the current that runs from the base to the emitter over here, and IC is the current that is allowed to run from the collector to the emitter. So depending on what you're doing at the base and whether there is a current being able to flow through the collector to the emitter, this base current controls the collector current. That's how you can think about it. And then this beta value determines how strong this control is. The larger beta, the larger that the current amplification is. So when you're designing a fuzz pedal, you want to know exactly what this beta value is, because the way that a fuzz works is that you have this complicated feedback loop of transistors, and it doesn't allow for the emitter resistor that you usually use to neglect the beta value in a more standard distortion pedal. But that's not the topic of this video. In this video I'm going to talk about how I used my Arduino to measure the beta value of some transistors. And for that I made a little circuit, and I exported some data to Python to do some data analysis. So let me first show you the circuit. To change the values of the incoming current, I use the potentiometer in the form of a trim pot that is connected to the high voltage, which I'm gonna call VT. Then I send this through another resistor to the base of my transistor. And here I add my first 2 Arduino pins. With the Arduino analog pins, you can calculate the voltage compared to ground. I'm just going to call this one VB and this one VB prime, and this means voltage compared to ground. And then I'm going to call this resistor RB because this is the base of the transistor. And I added a little resistor here that goes to the voltage, and then this goes to ground. And then I also measured the voltage over here, and this one I will call VC because this is the collector. Now that we have this circuit, the way that I used it is I of course connected these 3 to my analog Arduino pins, and then I turned the trim pot while the code was running so that I could get a large sampling size for different values in the transistor. Oh yeah, this resistor I'm going to call R. And then I got a lot of different measurements for these voltages. Using those I can calculate the currents, and with that I can calculate the beta value. So the base current is very easy. The base current is just going to be, with using Ohm's law, of course, current is voltage over resistance. And using Kirchhoff's law, we know that this is the same as the current through RB, because the currents only go this way and this way through the transistor. It works as a diode. So there's no current going from B to C in an usually. There can be a little bit of trickle current maybe, but we don't care about that. So this is going to be VB minus VB prime divided by RB, and that will give us the current through this resistor, and that's the same as the base current. For the collector current, I had to do a little bit more math. I won't bore you with the details, but you can check it if you want. I've got it worked out here. I calculated it to be the total voltage divided by, maybe you can simplify it, but I'm using NumPy to calculate it, so it's not a large effort to do this calculation. So this way I can calculate the two currents using the voltage measurements from the Arduino. And then now I think it's time to go into Python and see how I calculated the beta value. Okay, so here you see my code, and here you see the plot. So let me zoom in on that. So all the blue dots and the red dots are the data that I measured, and I want to automatically be able to just have the program spit out the beta value in one time, of course, but these horizontal dots at what's called the saturation region of the transistor, they're not useful for measuring this. And these flat dots at the end also, this is the I don't know the correct word, but it's like the lagging current. So what I care about is the steepness of this line over here. And by the way, I'm plotting the base current against the collector current calculated with my code. So I throw away all the blue dots, and those are just at the extremes. And then I just have the code plot a line through only the red dots. And then here you can see the formula for that line. And you can see that the beta value for this transistor was 161. And that's how you calculate the beta value of a transistor. So in case you're curious, why do you have to do this yourself? And the answer is basically that it's very difficult for manufacturers to build transistors with exact beta values. So I tested the batch that I have in just one batch of transistors that I bought, and I'll show you a picture of all the values that I found. You can see that they range from about 140 to 180. So that's already sort of a big difference, but it's not huge. And by the way, the beta value also changes based on your total voltage. So all these measurements were made with using my 5V from my Arduino. Additionally, if you look at the same model from different batches, I found results that ranged from 110 all the way to 230, or even 300, sorry. So that's almost a factor of 3 bigger in the same model type of transistor. It's just different batches from different times and stuff. So yeah, that was how to calculate the beta value of a transistor. I hope you learned something, and if you have any questions, make sure to leave them in the comments, and I will respond to them to the best of my ability. See you in the next one. Bye.